So anyway, it is a pleasure to be here, and uh, one of the things that happened to me in my life is that I started coming to Florida when I was a young kid because my dad loved Florida, and we had a home in Pompano Beach on the other coast, and we had hurricanes there too, and so I thought it was a great combination, being able to see them down here and being able to see them up there, and so it sort of fit. And all through my career, as I moved west, through the Midwest to get educated and starting working, and then very soon after that to be in Boulder, Colorado, where I still have a home and 4 children. I will say that I've never really sort of given up my love for the water, and it was natural for me to come down here as I was getting older and could afford to buy real estate. I did migrate to Longboat Key and had a home on the north end of Longboat Key where there was all kinds of water issues, and I helped the town of Longboat Key in recent years with, I don't know how many times, speaking to their town government, and they've done some really good things on Longboat Key to help minimize the impacts of a warming climate. Let me just ask you here, how many people think the climate has changed since 1990? How many people think sea level has risen since 1990? Okay. How many people think hurricanes are worse than they were? Okay. Okay, so you guys are all like, I don't know what I'm going to tell you. You already know. So, but what I'm going to say is that after running the National Center for Atmospheric Research as a director of the corporation that manages that center, it's an amazing center. It is a 1,000 scientists and engineers from all over the world. We have supercomputers, an Air Force, literally 13 airplanes. It's big science. And no university could afford to do this kind of science that is done at the National Center. The first climate model that ever ran on a supercomputer was a Cray supercomputer that was actually built for the National Center by Seymour Cray himself, and I was there when he did it and helped write some of the software for it. And a few years later, in the 1980s, it started predicting global climate warming, and at first we thought there was something wrong with the model because it was predicting such a rapid warming, but then we got smart and we started running it without carbon, the carbon footprint of humankind, and then with it. And the climate did not warm without it. It just warmed with it. And so the footprint of humankind has made a huge impact on the climate. When I came down here, there was one thing that really, and it still does, really bothers me, is that science is way ahead of where we are. We don't realize how fast science has made advances. You've heard of GPT, right? You've been reading about that, how this new artificial intelligence thing. They've released that now, and we can use that. We can ask it questions. I just want to tell you that that's ancient compared to what we can do. It's 2 generations ahead of that now, but you won't see that for 20 more years because it's being used in our military, for example. What we have accomplished in learning and how fast we're doing it is astounding. All of human knowledge is doubling now every year. Every year we are doubling the knowledge that it took 4.5 billion years to create. It's just an amazing thing that's going on. So when people tell me we're victims and we can't do anything about it and we can't do, that's just not it. That's it's not true, and it's not productive to think that way, because actually we can do a lot. And even though we're in a lot of hot water, so to speak, I do think that we have some opportunities to better the situation. And listening to the pastor give his blessing, it came into my mind that the difference between us and every other species is that we have a carbon brain, but we also have free will. We're the only species that has ever had that on this earth. And that means we get to decide what happens. Whether we want responsibility for it or not, we get to decide. Not deciding is a decision. And that's where we pretty much have been now. So this gap between what science knows and what society understands is what has bothered me, and that's why we set the Climate Center. We're at ground zero. You are sitting at ground zero right where we're sitting, 5 feet above sea level on the west coast of Florida with a narrow continental shelf and ever-increasing hurricane activity. And so our choices are we could leave, or we can reduce our risk and eventually solve this problem if we all work together. And we have the ability to do that and have done it before. So I'm optimistic. But the triple threat of water, which is what our Florida climate conference, I call it the Super Bowl of climate conferences. And it really was this year. Partly I called it that because the Super Bowl was the next Sunday. And so it seemed like the right thing to say. But it actually turned out to be that, and believe it or not, when it was over, I did go to Disney World, and I brought my granddaughter there. So anyway, there's 3 components of what we talked about at the conference, and one was sea level rise, storm surge, and extreme precipitation. I'm going to talk today about storm surge, because I think really the most risky thing we could have here is storm surge, because I don't think a lot of people really get the magnitude of what it is. So basically it's the rapid rise of water above the usual tidal position that we have with high and low tide. And hurricanes are usually the cause of storm surges. And I want to talk a little bit about what a hurricane does. And this is the eye of the storm, and you've all seen this on TV, and it circles around in a counterclockwise position. And you see these spiral bands. You've always heard, oh, the spiral band's coming over. It rains like hell. The wind picks up, and then it calms down for a while, and then another one comes over. And eventually you move into the eye where it's really, really dangerous. And so if this is Florida over here, let's say that this is us. And this was pretty much the way it was in Hurricane Ian. Our wind comes off the Florida shore and blows out to sea, so we don't get a storm surge here when we're in that position. But if you're on this side of the storm, and this is Fort Myers right here in this example, that wind is blowing right on shore. And when it does, and it blows at the force of 150 miles an hour, it's blowing a mountain of water onto the shore. And that's what creates this surge. So we've actually seen hurricanes here like Irma that blew all the water out of Sarasota Bay because we were on the north side. We've been very fortunate, even though we had a hurricane here. As I have said before, I don't want to hear again anybody tell me that the Indian princess is protecting us now. So this is a rather dramatic graph here. This goes back to 1980. And the spikes there are the number of storms in a single season that go through what we call a rapid intensification cycle, where the winds in the storm increase more than 50 miles per hour in 24 hours. That used to be a rare event back in the 1970s and 80s. It would happen maybe once every 10 years. And now in some years, it's happening 4 times a year. And in Hurricane Ian, it happened twice in 48 hours, which made it what it was. But as the Earth has been warming up, and it's warmed up quite a bit, it's warmed up, in general, it's warmed up 2 degrees centigrade, which is, it doesn't sound like a lot. It's 1.5, just approaching 1.5 degrees centigrade right now. But that's about 3 degrees Fahrenheit, roughly. But the ocean, which is 75% of the Earth, 78%, is warmed slower than the land. So the land is actually warmed up quite a bit more than that. And the poles have warmed up twice the rate that Florida has warmed up. So we're having a differential heating. Not all the areas of the Earth are warming uniformly. So in a hurricane, which moves counterclockwise, this is a side view, and in the middle is a clear column where the air actually descends from the top, and as it comes down, it dries due to compression of the air pressure. As you add pressure to a column of air, the temperature warms as it moves down. And so that's why, like, if you live in Colorado and you live on the lee side of a mountain and the winds come over the mountain, it could be like 0 on the top of the mountain. By the time it gets down into Boulder, it's 70 degrees because it's warming as it's coming down the side of the mountain by compression. The same thing happens in the eye of a hurricane, and that's why it's clear in the center of the hurricane, and all hell is breaking loose all around it. So I want to talk about how a storm surge forms, because in the eye of a hurricane, the pressure, the atmospheric pressure, which is the pressure of the air on the Earth's surface that keeps us on the ground, is strong. But as the hurricane itself, and you have that eye, the pressure in the eye is low. It gets lower and lower and lower the stronger it gets. And what that means is that the force of the air on the surface of the water becomes less and less. And as that happens, and the water bubbles up in the eye, it actually builds like a mountain of water in the eye because the pressure is not keeping it down. So it's like if you had a balloon and you press your hand down on it, you squish it, but when you let it up, it rises. And that's what happens to the water in the center of the eye. So if you look at this, in the eye of the storm, here's the normal sea level right here, and here's the continental shelf. And then you have this blue bubble here. And this blue bubble is the rising air in the eye, that the warm air and the low pressure, it makes the water rise in that bubble. And if that eye comes ashore, around that eye is where the storm surge is, especially where the wind is blowing onto the shoreline. So that's what creates a storm surge. It's the wind and the bubble of the water in the eye. And so what we have is sort of like a bad situation, okay, because we have increasingly strong hurricanes. The Gulf of Mexico is 5 degrees warmer than it was in 1990. Why are we having a red tide? Because the Gulf of Mexico doesn't get cold enough in the winter to kill the brevis, which is red tide, which is normal here to have some. But then you have a warming Gulf of Mexico, and that brevis doesn't die. It passes on from year to year, and it starts off at a higher level. And we'll talk more about what initiated it this time. Then we have more and more people that want to live here. Can you imagine what's going on here in the last 20 years since I started coming? There was no lights in downtown Sarasota at night when I first got here. No street lights. It's amazing. There was nothing down there to go to. And South Longboat Key always had something going on. And this area always had something going on. But there wasn't a heck of a lot going on other than that. Now we have 22 million people living in Florida, and they're coming 1,000 people a day. And guess where they want to go? Right where we are. Everybody wants to be here. It's a great place to live, except for the 2 or 3 days a year when it isn't. Okay? And then also the summers are pretty hot. Then, of course, higher sea levels have been a result of the air warming. When air warms and the seas warms, they expand. You know, think about putting a glass of water in your refrigerator and putting a mark on it. When you freeze that ice, the water level goes down. But you take that ice out and you take it out and warm it up, and you notice that that water level goes up. So the seas have expanded and the sea levels have risen because of climate warming. And now we have the added inputs of melting glaciers and the melting Greenland and Antarctica, and that's starting to add significant amount of water to sea level rise. So this is the NOAA map of storm surge. The thing about hurricanes is that they're moving closer and closer to the west coast of Florida as the climate warms, because the whole weather pattern is shifting, because the difference in temperature between the pole and the equator is going down. So that is realigning the storm paths, and they're coming closer to the west coast of Florida, so that's not good. They're also moving more slowly because the jet streams have slowed down, and that means hurricanes that used to move through at 20 miles an hour are now moving through at 10 miles an hour. So if they're going half the speed, they're over 1 point, twice as long, and they're doing more damage because of that, even if they weren't getting stronger. So a relatively small storm now can do a lot more damage than one that hit in, say, 1990 that was moving twice as fast. Even Hurricane Charlie, which hit right over the same area that Ian hit, was moving twice as fast, and it was only half as big. So therefore, Ian was over Fort Myers for 4 times the length of time that Charlie was. So it did exponentially more damage. This is really quite an image here. This is from 2017 on. We have had 6 catastrophic hurricanes hit the Gulf Coast since 2017. These hurricanes have done $450 billion of damage. I mean, that's getting to be serious money. And they've killed 1,000 people. Even with the technology and the warnings and everything else that we have these days, they are still lethal if people do not pay attention to what's going on. Ian, for example, is the largest hurricane ever to hit us in Florida as far as damage. So far, $114 billion of damage. The state of Florida has a gross product of about $1.1 trillion a year. So within 2 days, 10% of the entire wherewithal of the state of Florida for 1 year was wiped out by a hurricane. Other storms like Ida and Laura and Michael, which was a Category 5 in northern Florida and just missed us. Irma, we all remember, that was a big storm because it went right up the center of the state and did $90 billion. Not quite as much as we had. But you know, in Texas, they always do things bigger than they do in Florida. So Harvey was the most expensive at $151 billion. So this is a map of Florida, and the most important thing about this is, and I want you to take this away. First of all, I'm just going to ask you a question. How many of you know your elevation, where you live? Put your hands up. That's amazing. Okay, that's more than, how many don't know? Okay, so your assignment is to go home and figure out what your elevation is. Why? Because turns out that when Ian hit Fort Myers Beach, people didn't evacuate because they thought they'd be fine. They were living at 5 feet above sea level, and they knew the storm surge predicted was 12 to 18 feet. So if you add 5 feet to your roof line, if you live in a ranch house, let's say, 8, that's 13. If it gets to 13 feet, you're dead. So you got to put 1 plus 1 together. You got to use your carbon brain to figure out like what your risk is. You need to know your personal risk. Florida is, the red and light green areas are all below 10 feet. So the surge in Charlie, in Ian, was 15 feet minimum. Had that wave hit us, it would have gone all the way to I-75. All the way. Do you know in Fort Myers Beach, it went inland 15 miles from the coast? 15 miles. So this is not something you mess with, you know. When you hear these warnings and you decide, well, they tell you you have to leave, and then you know that it's up to you to leave or not leave. But not leaving is not really the smartest thing you could do if you're a human being and you have a carbon brain. Not too smart. So it's inconvenient. You know, I mean, you go home and your house is fine, you should, you know, kiss the ground, right? Not complain that it was inconvenient. But you got to know in advance, where am I going? Am I taking my car with me? Am I taking my electric car with me? What are you going to do when the power's out? Okay. So local factors can impact storm surge, and there's a lot of different ones, but the continental shelf being so mild here, you go out 1,000 miles, 100 miles, and the water is still only 20 feet deep out there. And then it drops off thousands of feet. On the East Coast, you walk into that water and you're out 5 feet from the shore and you're already up to your neck. Okay, so that matters for storm surge. Storm surges are bigger when the continental shelf is shallow. That's what we have here. In Miami, they get bigger waves because there's more water to blow up onto the shoreline, so the wave action is bigger. But the storm surge is a lot smaller on the East Coast than it is on the West Coast. So that is something we need to think about. It's unique to where we live. Higher onshore winds, as I said, are going to blow that water onto the shoreline. If you have a 150 mile an hour wind blowing perpendicular to the shore, a lot of water is going to come along. The storms are also a lot larger, and what I want to do is show you here the path of Ian. When it was south of Cuba, that yellow area, it was only a tropical storm. And then you could see how it all of a sudden turned red, and that was the first rapid intensification that went on just south of Cuba, and the winds went from basically 90 miles an hour, basically 50 miles an hour to well over 100 miles an hour in 24 hours. And so those people in Cuba really did not have much time to get ready. And it was a lot stronger, a lot quicker than people thought. They get storm surge there too. It's very flat on the west side of Cuba. In fact, their entire tobacco crop was wiped out, and 100,000 homes were destroyed in Cuba. 100,000 homes. Then it got off the coast north of Havana, and this is really a remarkable story because last year, the 2021 climate conference, which was in November, we forecast that a storm would take this course very quickly in the next few years and would hit with unprecedented force because of all the changes we were seeing with the warming, with how high sea level has risen. By the way, it's risen 9 inches here, 9 inches since 1950. And it's rising double the rate it rose in 1990 today. So we're not getting ahead of the story. We're still behind the 8 ball here. So we drew a little square on the map north of Cuba, and we said if a storm were to go across Cuba and get into this little square, all hell's going to break loose in southwest Florida. And 10 months later, we had this storm. So we do know what we're talking about, even though we didn't know what day it was going to hit back in last November. But we knew the conditions were lining up for something big. And you can see how when it went off the coast of Cuba, now the line is red, and then it became deep red. It went to a second rapid intensification cycle after it moved off the north coast of Cuba and became a 155 mile an hour Category 4 storm. 2 more miles an hour, it would have been a Category 5. So I mean, literally, the difference between a 75 mile an hour hurricane from a force of the wind and 155 miles an hour is 4,000 times the damage. It's not double, because wind pressure is exponential. It is not linear. People don't realize a 5 mile an hour increase in a wind speed in a hurricane is a big deal. A 50 mile an hour wind, I've only seen that rarely. And this is the first hurricane in my 50-year career that ever went through 2 of them on successive days. I've never seen it before. Ladies and gentlemen, the climate has already changed. It's not a prediction, it's a fact. It's not something that's going to happen in the future. It's something that's already happened. And it will continue to happen until we do something about it. So this is what it looks like on the Weather Channel, and you can see on the south side of the storm surge comes as the winds are blowing inland, and to make matters worse, it's a concave shoreline there, so it gathers the water and it actually magnifies the storm surge. But this is the NOAA storm surge prediction model 24 hours before it struck. That purple area is 15 to 18 feet of storm surge. That was the prediction. 80 people drowned in Fort Myers, knowing that a 15 to 18 foot storm surge was coming, because they did not know their elevation. So we're making T-shirts right now. The front of it's with our little lighthouse. You know what that lighthouse is? It's the Ponce de Leon Lighthouse. It's on the east coast of Florida, and when the Spanish came over and discovered the New World here in Florida, they built that lighthouse as a beacon of where people needed to go as they were approaching the New World. And if we're going to make it to the New World through climate change, we need a lighthouse, and we hope that the CAC is part of that. And that's why we selected that as our corporate logo. But the fact is that science really had this right, but people did not trust the science. And so they ignored at their own peril, and 160 people died down there. 80 of them drowned. 80. So now I'm going to show you something that, I'm going to show you 2 things.
sounds was enchanting, completely.
Not that. So this is Ian off of Venezuela as a group of showers. These are different views from our NOAA satellites, some visible, some infrared, and you can see how it's starting to organize, and then it forms an eye. As it's moving toward Cuba, this is the lightning strikes when it's north of Cuba, moving toward southwest Florida. You can see the spinning top, and this is an absolutely epic hurricane. Huge, twice as big as any hurricane was back in the day. This is the eye when it's going through a intensification cycle just before it hit. And when it hit, the runoff off the shore was epic, and the damage was complete. So complete, there wasn't any debris left on a lot of the places it hit. Look at that lightning as that eye comes ashore. It's unbelievable how strong this was. The eye increased in size from 12 miles to 30 miles wide just before it hit. Now I'm going to show you something you've probably never seen before. And if you have, I'll buy you a drink. Well, let's see if I can get back to this. How do I do that now? Escape. Okay. Usually I have somebody doing this. Let me put my glasses on so I can see. All right, let's see here. Here we go. Shoot. Oh, here we go. All right, let's see here. I need whoever is running the show to come and help me figure this, how to get back to the screen. I'm sorry, I didn't hear you. Hi. Can you get, I'm sorry, that's okay. I'm not used to using Chrome, and I guess, I'm thinking this is my own computer. There you go. All right, thank you so much. So now, this is amazing. And this is what a storm surge looks like. A meteorologist, the day before, went down and put a camera to video this, right where the prediction said it was coming in, and then left. And this is it.
I have Parkinson's disease, and I have chronic arthritis in my.
Notice these palm trees, and notice the way they're blowing. Notice that red house. This is a 4-hour time lapse. This is the same elevation as Longboat Key and the same elevation of where we're sitting. Notice the red house. Now look where the house is. Now you're going to see something interesting happen now. You see how those trees are blowing from the ocean inland? Now watch what happens when the eye goes by. The eye is right on the shore right now. Okay, the eye is going by. Now watch the direction of the wind. You can sort of see it shifting. Now look at it. It's blowing all the wind back, all the water back out into the ocean, out into the Gulf of Mexico. And that's what it looks like 4 hours later. Would you want to be there if you could have been someplace else?
I don't want to run my boat out in the water.
Now let's see if I can get him back again. One more time.
Yeah, just this tab right up here. Boom. There.
Oh, okay, great. Thank you. Okay, now this is a very unique picture. Ooh, I think I must have the, This is a multispectral image from one of our new satellites. And it's looking down inside the eye, inside the storm. So this is the storm, and that's the eye, and this is the eye of the storm right here. And this is something going on. This is the old eye right here that was 12 miles long. And you can see this looks like another eye is forming outside of the original eye. So this right here is what the original eye of the storm was. 6 hours later, the eye went from this to this. And these red bands here are the severe thunderstorms around that eye. So what happened is not so much that the hurricane shifted direction, but the eye expanded onto the shore as it grew. So we had what we call not only two rapid intensification cycles, but the eye replaced itself right off the coast. This is one of the greatest satellite pictures I've ever seen. This is looking down into that blue, that's the ocean inside the eye of that storm. And we overlaid the map of Florida on it so you could see. Imagine that this storm could have been a category 1 or 2 and then been a 5 when it hit, all within 6 to 12 hours. So these storms are different than they used to be. We used to have days warning when these things happen. Now it can happen in a matter of hours. So even if it's a category 1 or 2 coming, it's not safe to think it can't intensify. I'm going to show you why it intensified, and these things are the things that we knew. This is the sea surface temperature. This is the island of Cuba. And this red area, south of Cuba, is 5 degrees warmer than normal ocean temperature. Notice there's 2 areas. One is right here, and one is right off the coast of southwest Florida. Guess what? The hurricane went over both of them. And each time it did, it went through an explosion of intensity. Hot water is rocket fuel for hurricanes. The reason we're having stronger hurricanes is because the oceans are warmer and provide the energy to the storms to become so intense. This is what it looked like from hurricane force winds in the red. This is why I say the Indian Princess failed us this time, because even in Sarasota, we had 106-mile-an-hour winds. And this is what it looked like. Notice the building right here. This is a Category 5 building that survived. It's a new building. But look at the devastation to the north of it. I mean, these It looks like an A-bomb hit this area. Now this is the other side of the building. And I want you to notice these little man-made things like this. Guess what? The storm surge went right down those man-made canals. And that's why it went 15 miles inland. We did that because our design did not include thinking about this kind of thing. Just like our traffic circle, which I know you don't like because you don't like the traffic, but there's other issues with that. As you get off the bridge, entering that traffic circle, it's only 2 feet above sea level. They just spent millions of dollars to make that traffic circle, and they didn't raise the road. So the first thing that's going to go underwater when we have a hurricane is going to be that area. And you guys are the ones who will be what's the opposite of beneficiary? This is what it looked like on the other side of the island. I mean, there's nothing left. This is on the inland side, and it still wiped everything out. So Hurricane Ian had winds of 155 miles an hour. It moved half the speed. It was twice as big, and it had a storm surge of 15 feet, and it rained 24 inches and created the biggest runoff in 200 years that flooded into the Gulf of Mexico loaded with sewage, loaded with farm fertilizers and golf course fertilizers and yard fertilizers and septic tank effluents. The water shot that went into the Gulf of Mexico was 300 miles out into the Gulf, and it was still 4 inches of fresh water on top. And in that was the seeding of the epic red tide that we're experiencing today. So when people say, oh, well, this is all natural, yeah, it was all natural to a point until we got involved with it and made it worse. And you can't fix something that you don't really take responsibility for. And so 5,000 homes in Florida were totally destroyed. 35,000 homes were badly damaged. 350,000 cars were destroyed in Florida. Many because they weren't moved. With 24 hours notice, do you think somebody could move their car? We have hundreds of parking garages on the mainland that were empty. All people had to do was get in their car and go to the parking garage. How come you can go to St. Armand's Circle and reserve a parking space on the parking app, but you can't go to a parking garage in a hurricane and know what parking space you're going to be and have somebody there to pick you up and take you to a shelter? We have that technology. Nobody's doing it. Why not? Whose fault is it? Anybody got an idea? It's your fault. You know why? You don't ask for it. You're writing your checks every year, sending it in, and you say, well, that's not my thing. I paid my taxes. But they're building roads and not raising them. They're building new art centers, and some of them are below sea level. And there are some people that think they should repurpose that into a new symphony hall or whatever, performing arts center. It's below sea level. The stage is below sea level. Why would you spend $100 million to do that? I don't know. So every area in Florida had gale force winds. And then Nicole came by on the East Coast. It's the latest hurricane ever to hit southeast Florida. It was much weaker, but it too was big, and it took this path, and we had some impacts from that too. But the storm surge was on the East Coast this time, but notice how small it was compared to what we had on the West Coast. Part of that is the continental shelf, and the other part of it is that the storm itself is a lot weaker. But still, it was massive, and it covered the entire state of Florida with gale force winds at one time. So I just want to show you two things. One is, this is the area in a Category 2 hurricane. The red area will be 9 feet underwater in a Category 2 hurricane. This is Southwest Florida. It doesn't take a Category 4 hurricane. It takes a Category 2 hurricane that's moving the right way. And I'm going to show you what it looks like right here. This is a Category 2 hurricane, not a Category 4. That's 9 feet of water in St. Armand's Circle potential. So when a hurricane's coming, get the hell out. Don't wait. Because when everybody else starts moving off, we could have serious issues with the ability to get off. And this is all the way up to Anna Maria Island and all the way into Tampa Bay, a Category 2 with having the max potential it can have, can do 9 feet of storm surge in all these areas that are in red. So that's my story. And I want to just say this to you. I'm not here to entertain you, although I am. I love entertaining, okay? So, and I like to give a good talk. But the whole idea here is to stimulate your own thinking. This is not somebody else's problem. We're still alive. It's our problem. It's not for a future generation to fix. It's for us. We're the ones with the power, the money, and the intelligence, and the experience, and the wisdom, and we need to use it. So I would like to see all of you get more active in knowing. Before you can fix something, you have to know. Now that you know, we have to do, and we have to do it together. And one of the things you can do is be part of the Climate Center and help us do what we do better. The more people that we can have, I'd love to have another scientist like myself to go out and brief the communities. In fact, I'm going to Longboat Key next week to meet the new town manager. One of the first things he wanted was to meet with us. This guy obviously gets it. He lives on a barrier island. He knows what the risk is. But so many people don't. And they don't care. And the problem is, if you know and you don't care, you still don't do anything. So that's your choice. And I hope you'll make the right choice. And I hope you'll help us be more effective on what we do. So could we have some questions now?
It's kind of comical. They cut down all the Australian pines to clear the navigation. I mean,
You know, I lived on North Longboat Key when they did that, and the first thing that happened is Bear Can Island started washing away. And then they spent $10 million to fix that problem, and I helped design that solution myself. But I was vehemently against it. They said, well, it's not native. And I said, look, in a climate-warmed world, we're not going to have native plants because plants are going to grow here that never would grow here before.
and then we put a circle downtown.
Well, and not,
Quite key to getting out of here.
well, the whole point is the circle isn't the problem. It's the fact they didn't elevate the approach to it. Well, it could be a problem, but I'm not here to say whether it's a traffic issue or not. I'm here to protect life and property, and your lives in particular. Yes.
Again, you know, they are predicting that we're gonna have Category 6 hurricanes. And I have to tell you that, I mean, I live right on Lido Beach, and with, Irma, they predicted a 16-foot storm surge right on.
And that's what you would have had if it stayed right on the coastline.
Yeah, but again, you cannot believe how many people stayed
Right,
in my building.
right. And they think they've missed it before, therefore they'll miss it again. And by the time you know you're not going to be missed, it's too late to leave. Yes, let me get this gentleman.
So Hurricane Andrew was letter A, and then these recent superstorms were all letter I and letter H. Is there
How-
significance to
Well, that's because I'm telling you this, in the last 3 years, we've had 65 named storms. The average hurricane season back in 1990 was 12 per year. In the last 3 years, we've had 65.
And Andrew was late in the year, end of August.
It was at the end of August, and it was the first storm of the year.
Yeah.
Hurricanes used to start forming in August and run through September and early October. That was it. And now they're starting, the 1st of May, and they go into December sometimes. In a few more years, in like 30 years, I'm expecting another 20 inches another 12 inches of sea level rise here by 2050. And more hurricanes, maybe double the amount of severe hurricanes that we have today.
Well, if they have to retire all these I names, we're gonna run out of I names.
Aye, aye, aye. Yes, in the back.
Don't you think we're not dealing with a scientific problem, we're dealing with a philosophical problem? But you know the Bible, it says, only the idiots build a house on sand and not on rock. And, you can have a wonderful data that you can have. Look at people have all the data, what keeps them alive and well, but what do? Ignore them. So I think this is a philosophical problem, and the AI should be really a real intelligence that has to be communicated. But the question is,
Yeah.
who can communicate it and dictate it efficiently? I know all about the science and so on, but who is in the decision-making position? And I don't see anybody who gets it.
Okay, so I'm a decision maker because I decided to do this. And so I'm doing it. And you're a decision maker when you go to the voting booth. You're a decision maker when you decide not to show up at the town meeting or to go. You're a decision maker when you invest your money. What are you investing it in? Are you investing it in the climate economy, or are you investing it in the old economy? Are you, when you go and you buy products, did you know that products made in China have twice the carbon footprint as the same products made in the United States? But you go to Walmart and Amazon and you'll buy those. Why do you do that?
Yeah, but what is made in USA anymore? I mean, seems like.
Well, no, seriously, a lot of things would be made in the USA.
Name one, please.
Cars.
Okay. Are we still making cars in Michigan?
Yes, we make millions of cars.
Okay.
Millions. I mean,
All the parts are made in the USA.
well, I didn't say all the parts, but what I'm saying is the United States is still the second largest manufacturing economy in the world. And the reason it's not number one is because we shifted our manufacturing offshore to save a dime, but we didn't care about doubling of the carbon footprint to make those products. If you buy American products or European products or products made with clean energy, regardless of what country they're made in, if you would take that as a responsibility when you bought, and you can find those things out, you could change what's made in here and what's made with clean energy. You make these choices every single day. Let me give you another example. 40% of all the food in the world is wasted. Yes, it's thrown away. We have a lot of people starving in the world.
Or just in USA?
No, in the whole world. In the whole world. So, when you go to a restaurant and you order an entree and you leave half of it on your plate, where do you think it goes? It goes into the landfill, and you know what happens when it gets in there? It degrades and it produces methane. And did you know that methane is 50 times worse as a greenhouse gas as CO2? So buy what you eat. You can do that. Or, if you have waste, compost it. And by the way, go to your town meeting and you tell them that we want a compost bin in every new house or every remodeled house that's built, and we want someone to collect it and recycle it and build up our soil rather than build up the methane in the atmosphere. Every single one of these things you're empowered to do. You just have to take the responsibility. You can't do it unless you know, and you're not going to know unless you're interested. Yes.
I live here from since 1992, okay, from New York. And nobody or many people don't know we have problems because right now I find out from Bird Key to the circle is not belong to Sarasota, is belong to a Florida Highway Department.
Right.
So the city and they're fighting who have the money and what they do and whatnot.
Okay, so that's
And-
an excellent
And
point.
I lived through 2 hurricanes, 2017, and this time I stayed in a condo that's like a 3-level 1965 built little condo across from the yacht club. Okay, thank God 3rd floor hurricane windows. I would not do it again.
So,
And even we get lucky because we get lucky. Okay?
yeah.
And I don't see, you are doing fantastic, okay? But look at this, how many of us in here? It's not too many people who speak up and fight about it. And I don't see really we paying attention how we going to better or for us. We pay $7 million condos we building. Look at this what's happening. Building, it's like building Dubai over here to me. And, you know, even in the cops, they're joking about the suicidal circles we're doing. And now I don't even know that there was a not sea level. And the leaders in here, what I find out, I don't know, it's corruption. I don't know how should I. But I'm very frustrated and I'm scared.
Yes, and you should
And
be.
I'm
And
getting not younger, and I'm like, where I should go.
Psychiatrist for frustration.
yeah, I mean, but there's a couple of things, right? The human condition is what it is. All right. Somehow, one of the things that happened in the last 200 years is we went from 1 billion people on this earth to 8. Human beings have been very, very successful at certain things. But what I want to say to you is you have to be optimistic. Nobody ever solves a problem coming from a pessimistic point of view. I don't know a single thing that's ever been fixed. So I get up every day and I do what I can. Is it going to be enough? I don't know. But I'm working at it every single day. And I'm not sitting thinking, I'm going to fail. I mean, my career is way beyond anything I ever imagined it would be, okay? But I've accepted it. I've accepted the role I have, and I work at it every day. I'm not saying that you should all go back to work. I'm just saying that pick 5 things you're going to do and then do it. If we have millions and millions of people that are inspired by what other people do, it only takes 10% of a society to change the society totally, not 51%. So if you want to be part of the solution, do it. You're armed with the information. If you go to our YouTube channel, you can watch. There's a 25-minute presentation about what you can do. Pick 5 of those things and do it.
How do we find the YouTube?
It's called the Climate Adaptation Center on YouTube. And you go to the 2023 Florida Climate Conference. There's 16 videos. We had people from all over the world here speaking. And I'm talking about the top people. The people in Sarasota County or in Bradenton County, the government officials could have come and heard this. We brought it for them. They didn't come. Why? Nobody's asking them to come. I asked them to come. I'm just a scientist. But I pay and my taxes are pretty high. I don't mind paying my taxes, but I want to get something for my money. And if you're satisfied with what you're getting, that's a decision you're making. If you think you can't do anything to impact the outcome, I would say you're probably right, because that means you're not going to do anything, and you will impact the outcome, not for the good. Yes.
Yeah. How do you differentiate weather from climate?
Okay, I'm going to tell you, this is true. This is honest to God true. In 1985, when we started running the first climate models, I was a director of the University Corporation for Atmospheric Research at the time. The climate weather forecast, or the climate forecast for 2020, was being made in 1985. That's today's weather. The climate of 25 years ago is today's weather. So climate becomes the weather over time. So our climate is advancing, the weather is responding with a lag. All of the impacts we're having from a warming climate is the carbon that was put into the atmosphere years ago, not the climate we're putting in today. The stuff we're putting in today, we'll see in a decade, in 2 decades, in 3 decades. So we're going to have a lot more climate change until we change that equation.
So you compare A, and then you go to B over 20 years or 40 years, and you see that's a change and that is a climate?
Yeah, so the climate really is a statistical anomaly where you add all the weather up over a period of time. So one of the talks, and it was just amazing, we had the world's leading paleogeologist here. He discovered the largest dinosaur in the world, and guess where it was? He went all over the world, all over. Argentina, he found big ones down there, and they're unearthing them. He went to Egypt and found big dinosaurs over there. He has a whole crew. He's a world-famous guy in dinosaurs. Guess where he found it? 5 miles from his house in New Jersey. I am not kidding you. And next year, he's opening a museum, a $100 million museum, with this dinosaur they found in New Jersey. You're going to be able to see it. They're building it around this dinosaur, and the CAC is invited to go and bring our members for a special day at this new museum. And what he says is, and he sets me up in my talks now, he gives the first 4 million years of climate. There have been 5 mass extinctions. Every single one of them was caused by the climate. We're in the middle of one now where 69% of everything, our biosystem, is now dead. It's already been extincted.
Can you tell us a secret where this museum will be open? Because we are from New Jersey.
Yes, but it's not open yet. But you know Rowan University?
Yeah.
Outside of Philadelphia?
Yeah.
It's right out there.
Oh, okay, thank you.
He's a professor at Rowan.
I'm not a policeman, but in the design of the speaker series, formal program is supposed to be over by 6. And then we go informal. So we're not cutting off anybody who wants to stay and speak, but we're trying to have an environment where people who have to leave because of another commitment don't feel bad about getting up and walking
Right.
out.
Please do if you've, and I'll stay for a little while longer if you have more
We
questions.
just go informal, so that we don't cut anybody off but those who have other commitments and plans, other people to do so. And
I'll put off my martini for another 20 minutes anyway. Yes.
Is there any geographical or topographical explanation of why the bullseye of the hurricanes like Irma and Ian have missed Sarasota from the original forecast?
Well, so you have to understand that these models, the further, we started predicting that Irma was going to hit Florida when it was out off of the African coast 6,000 miles away. And the further you get out from strike time, the more the error is, because more things that can go haywire. And we don't measure every single place in the atmosphere perfectly, although we have trillions of bits of data now, that in my lifetime, you know, there wasn't even a computer when I started, okay? So, I mean, this is unbelievable. The iPhone now has more power than the supercomputer at NCAR did that predicted the first global warming in 1985. That's amazing. Yes, sir.
If the local officials don't even show up for these wonderful series of with scientists, should we have a moratorium of developing this part of Florida? Because how do you remedy your problem that you self-created?
Well, so here's the thing. Given the information we have, if I were just looking at the information, I would say there should be no new development below 4 feet above sea level, because the frequency of flooding is just going to get worse and worse. I'm not talking about a 15-foot storm surge. I'm talking about high tide. I'm talking about a tropical storm. I'm talking about a Category 1 hurricane. So, you know, when you you have to stop digging the hole deeper before you can dig out. And so far, we're still digging it deeper. We have to change that. Now, look, I don't want anybody to move away from the shore, because this is a great place. I live here too. It's a great place, but know your risk. Be ready. Know where you're going to go. Participate with your local governments and tell them what you want. Tell them to raise the roads with your money. Insist that they do it. They're elected. They listen to what the people say, but if nobody says anything, why would they don't hear anything? So they shouldn't do it unless people ask them to do it. Are you asking?
I can't believe that they didn't raise the road as you're going off, where it floods at high tide. I mean, it doesn't take a storm.
Well,
They're gonna raise this, don't worry.
so they did raise the circle itself, but not the approach. All the equipment's still down there. They could raise it right now. But it's not in the plan, and I've been told that it's going to get in the plan. And I said, well, when? Right? I don't know if we're going to have a hurricane next year. As far as I'm concerned, that could be fixed right now. Why wait? Why take a risk that doesn't need to be taken? Why put a life at risk that doesn't need to be at risk? I don't know. I'm just talking common sense here. This is not rocket science, and I am a rocket scientist. Yes.
Principalities ever said that, or thought about,
It's on.
if your house blows away or washes away, you can't build? Has anybody ever
If
thought of that?
51% of your home is damaged, you have to then level it and build it to.
Build it up, yeah, but still, that build-up's on longboats, I mean, you'd have to be 15 feet above.
Well, you know, I mean, there are structures on Mexico Beach and in Fort Myers Beach that survived the tidal wave because they were built to standards we can build them. So this is part of the answer. If we're going to be here, then we have to build structures that are climatized for the climate we're going to have. That doesn't mean that we have to be here when it hits, but at least we'll have some place to come back to.
We in New Jersey in 2012, we had Hurricane Sandy. We didn't have a problem with flooding,
Right.
but we had a problem with long wind storms, 150 miles an hour, and that stretched 1,000 miles inland and 1,000 miles south and north. What do you do in order to prevent these hurricane storms?
Well, so there's not, the thing we have to do there's two parts of the solution. The first one is we have to adapt to what is. And to adapt to what it is, we have to admit where we are. You can't, if you don't know where you are, how can you go someplace else?
We were higher elevation and still.
Okay, the second part, though, so our codes, our rules and regulations, how we build buildings, how we architect buildings, how we build roads, every single decision needs to have a climate screen as part of the decision-making process. It's not an afterthought. Okay, then we need to be at the same time lowering our carbon footprint, because the stuff in the atmosphere eventually will come out. And if we're not putting anything in, the climate will settle back into the way it used to be. It's going to take a while. But we have to build a bridge to the future
You say
before we do
we.
that, before that
Who
happens.
are we?
You, me,
People.
all of
But
us.
we don't have a voice.
Yes, you do.
Only when we go to the vote, and then somebody comes in and votes against what we want.
Ma'am, if 8 billion people made the choice to be
Yeah,
carbon efficient and not waste food, it would lower the carbon footprint of the world by 12%. That one thing.
That would be wonderful.
Well, you have to start at home. That's where it starts. It doesn't start with someone else. It starts from the bottom up.